So you want to learn how to graph trig equations. Well, I already blew the intro, but I've got two examples here to kind of help you, hopefully help you learn how to graph trig equations. I've got one that's pretty straightforward and one that's a little bit uglier. Let's look at the first one. Okay, so I want to graph this y equals 3 sine of pi over 2x minus 1. All right, and we'll try and graph in the negative direction and the positive direction. So the first thing I notice about this graph is that it has no horizontal shift. Okay, so I'm going to take a sine curve and it's not going to be shifted left or right at all. So no horizontal shift. There's a vertical shift, but we'll deal with that in a second. The first thing I want to figure out is what is the period of this function. All right, and I think to do that I know that the period is 2 pi over b. All right, well, in my equation, b is right here. It is pi over 2. So in other words, I want to know what is 2 pi over 2, divided by pi over 2. All right, well, if you remember from 5th grade fractions, I flip it and multiply, so I think that my period is going to be 4 units. Okay, so my period is 4. So that means that between 0 and 4, I'm going to complete one full cycle. I'm going to go up and then I'm going to go down. So it'll look something like this. Or I've got to complete one cycle in that amount of time. It's not going to look like that when we're done. But that's the period. Okay. That 3 is my amplitude. So my A equals 3. The amplitude is 3 units. And then the negative 1 is the vertical shift, or my D, in the standard form of the equation. The first thing I want to do is let's graph just 3 sine of x, or 3 sine of pi over 2x. All right, let's graph that first. All right, so the only thing that's different between the general sine curve and the only thing that's different between sine of pi over 2x and 3 sine of pi over 2x is the amplitude. Okay, so I know that just in general when I'm graphing a sine equation, I know that halfway between my entire period, I've got to cross the x-axis at some point. Okay, and I know that the amplitude is 3, and that it's 3, and that the curve will max out halfway between 0 and 2 for this example. So halfway between 0 and 2, the curve is going to max out at 3. Okay, so it's got to do one of these things, at least the beginning. All right, and then below, I know it's got to bottom out at negative 3, and that has to happen halfway between 2 and 4 in this example. Okay, so halfway between 2 and 4 is somewhere in here. All right, so then the curve comes up and lands like that. So remember that this is y equals 3 sine pi over 2x. And I ran out of space, but pi over 2x. All right, now I want to take this, and the only difference between what I've just graphed and my function that I've been given is a vertical shift of -1. So let's, in a different color now, let's actually graph this curve with a shift of -1. So that means I'm going to take every point and move it down 1 unit. So I'm going to start, instead of at 1, I'm going to start at -1. Instead of this point being at 1, 3, it's going to move down to 1, 2. Instead of this point being at 2, 0, the 0 here, it's going to move down to 2, -1. And instead of this point being at, I'm going to run right into my trial thing here, but it's going to be down here. Okay, so that's going to be my minimum, and then I'm going to complete my cycle here at 4, -1. So my graph will look something like this in red. And it'll keep going. Okay, now let's finish in the negative direction. So once again, I know that my period is 4, so if I go back the other way, I've got to complete this cycle at -4. We'll just continue with the red here. Okay, and I know that halfway between it, I'm going to kind of cut the axis of symmetry there. All right, and then I know this curve is going to continue down, but the question is, how far does it continue down? Well, we know that we bottom the curve out, or we have a minimum right there at -4. So I've got to have a minimum halfway between -2 and 0. So at 1 at negative y equals -4. So it'll bottom out right there at -1, -4. And it'll go up like this. And where is it going to max out? Well, this curve maxed out in the positive x direction at 1, 2. So it's going to be instead at -1, 2, 3, 2. So it'll have the same height. It'll just be half the distance between -2 and -4. Okay, so in red, this is my curve. Y equals 3 sine pi over 2 x minus 1. Okay, in red. So start with something that you know. All right, get the amplitude correct, and then shift it either horizontally or vertically from there. And sometimes you might have to do both, like in the next example. So I'm going to take that away. Let's go on to the next example. Okay, now this one's a little bit uglier. So the first thing that I'm going to do is notice that this is not in standard form. I've got to put this in standard form. All right, remember that standard form is y equals a times cosine. Actually, let's get rid of this parenthesis here. Whoops, got rid of a lot. Y equals a cosine of b times x minus c plus d, right? That's the standard form of the cosine function. Now, instead of having that in this form, though, I've got to get this pi out in front of the parentheses. And so I've got to factor out a pi. All right, so when I put this in standard form, I'm going to have 2 cosine pi, okay, times, when I take pi over x and divide it by pi, it'll leave me with just x, which is what I wanted. Okay. And then when I take -2 and divide it by pi, I think I'm just going to have minus 2 over pi. Okay. And then, of course, minus 1. So that's in standard form, proper standard form. Why does that matter? Because when I go to find my period, then come on, stop that. Okay, when I go to find my period, I'll do it over here. The period is 2 pi over b. Well, b in this case is pi, so my period is 2 units. Now that would be the same if we hadn't changed anything. But notice, I've got a horizontal shift right here. This -2 over pi means that I'm shifting it to the right 2 over pi units. Okay, so that's why it mattered, because if you take the first one in non-standard form, if you take that one, you're going to think that there's a shift of 2 units to the right. That is not the case. The shift is actually 2 over pi units. Okay, so let's start with just graphing cosine with an amplitude of 2 and a period of 2 units also. Okay, so I know that, and I'll just draw this in here. I've got to complete one cycle. In fact, yellow is not a very good color. Let's do blue here. I've got to complete one cycle in 2 units. Okay. Now cosine usually starts off at 1 and kind of starts off heading down. But since my amplitude is 2, cosine is going to start at 2. Okay. Now remember, I'm going to graph 2 cosine pi of x without the horizontal shift or without the vertical shift yet. Let's just see what 2 cosine pi x looks like. Okay, so it's going to start at 2. It's going to have an amplitude of 2. Halfway between 0 and 2, I've got to bottom out, or there's got to be a minimum. So down here at 1, 2 is going to be a minimum. And then I've got to complete my cycle over here at 2, 2, because I've got to get through one cycle in 2 units. So let me get rid of this line here, and let's draw what that looks like into the equation. Now actually we know that halfway here and halfway here are going to be my x-intercepts too. Okay, so down like this, like that. Okay, so that's the beginning, and then actually down again and so on. Okay, and it's going to keep going. Now remember, this is y equals 2 cosine of pi x. We have not done a vertical shift or a horizontal shift. I think it's a good idea to graph this first and then start moving it around. All right, so let's finish this curve out in the negative direction here. So we know that it's got to bottom out right here, and we know it's got to cross the x-axis halfway between -1 and 0 and -1, and also between -1 and -2. So it's going to bottom out like, so it's going to go like this. And then we know it's got to complete the cycle here at 2. Okay, and then so on. So it'll finish, and we'll kind of call that the end. Now, let me erase some of this stuff. So I know the period is 2 units. We already talked about that. You guys should know the general form of the sine curve. And now we're going to shift this thing. Okay, so let's shift this up. I want to shift it. I've got a horizontal shift of 2 over pi units, and then I've got a vertical shift of down 1. Let's do the vertical shift first, and then we'll draw in our final curve here. Okay, so let me stay with the blue, because this isn't our final curve. So I want to do a vertical shift down 1 unit. Okay, so I'm going to take this curve, my original 2 cosine pi x, and I'm going to shift it down 1 unit. So shift everything, all your important points, down 1 unit. Okay, so that one there, and then we're going to move this maximum down 1 unit. And so let's draw in the curve now. Oops. Oh. Okay, and shifting down 1 unit here, so it's going to bottom out in there somewhere, and so on. Okay, so we've shifted it down 1 unit. Better finish the graph. Okay, so that's a rough sketch of what has happened. Now, in red, let's actually draw that in. So we're getting pretty close now, right? We've taken our original, we know what the amplitude is, we've shifted it down 1 unit, and now I want to move it to the right pi over 2 units. So just to be clear, when it says negative 2 over pi for your horizontal shift, that means we're going to shift it right pi, or excuse me, 2 over pi, I think I said pi over 2 several times, 2 over pi units. Okay, I'm going to shift it to the right, 2 over pi units. Well, 2 over pi is approximately 2 over 3, so it's about 0.66, so it's going to be a little bit less than a unit to the right. So hopefully this doesn't get too messy here, but I'm going to shift this, let's see, from here to here is 1 unit, so I want to shift everything somewhere in between there. So maybe shift this unit over here to the right, like 0.6 roughly, and then I'm going to shift this point here about 0.6. Okay, I'm going to shift this point here about 0.6 units. I'm going to shift every point here in this bottom graph about 0.6 units. Okay, and you'll start to see what the curve will look like. Okay, so we've got that one. We want to shift this one about 0.6 units. Okay, and then you start to see what the graph looks like. Okay, and that's incredibly ugly. Okay, this one shifts to the right pi units. Okay, and so the white graph is the one that you're looking at. In fact, I think I can make that even better here. So let's actually draw it in red so you can see it. It's this one right here. Okay, so so hopefully that wasn't kind of too out of this world, but the basic fundamentals here are: get a good idea of what your graph looks like from the basic sine curve, or sine or cosine curve. Check what the amplitude is, and then start moving that thing horizontally and then vertically. horizontally and then vertically up or down. Okay, and that's pretty much it for graphing trig functions. Take a look, watch the video again. I apologize that this last one got kind of messy, but that's pretty much all there is to it.